Let's move on to the next homework problem. And for this question, I have a particle that moves along a straight line, and I need to find the position function of the particle at time t. So just remember, when you're trying to find the position function, s of t, the position function is really just the antiderivative of your velocity function with respect to the variable t there. Okay, so if we're trying to find the position function, let's just find the antiderivative of our velocity function. So if I rewrite our position function over here, we are simply now taking the antiderivative of our velocity function, which is 1 over the square root of 1 plus t, and then dt. And our condition is s of 3 equals to 1. Okay, so let's go ahead and find this antiderivative here, and we need to use a u substitution here. So what I'm going to do here is I'm going to highlight the 1 plus t there, and we're going to let u equal to 1 plus t. And if I take the derivative with respect to t, du over dt, this is going to be equal to 1. And just by kind of going ahead and looking at this integral here, this will be the integral of 1 over the square root of u. And we have a dt here, and if I just move this dt over from my u substitution step, I have du equals to, well, 1 times dt is going to be just a dt here, so du equals to dt. So just by using u substitution here, I know that the dt equals to du, so I'll put a du over here. Okay, so those are very common steps when you're executing a very simple u substitution step there. So let's go ahead and find the antiderivative here. So before we find the antiderivative, I would just rewrite this as u to the power of -1/2, and we're taking the antiderivative here with du. All right, so now this is now in a good situation where we can find the antiderivative. So the general rule is if you're given a power, you raise 1 to that power. So -1/2 plus 1 is going to be u to the power of 1/2, and then we divide by the new power, which is 1/2, and then we can add the plus c there. So our position function s of t is now shaping up to look like this. Then ask yourselves, what is u, right? Well, u at the beginning was 1 plus t, right? So let's go back and substitute 1 plus t there. So if I just keep on going here, put a little arrow here. So my new position function, s of t, is going to equal to, and I'll put this in brackets here, 1 plus t to the power of 1/2. And then you have this 1/2 on the denominator there. So if I just simplify that, that means I have a 2, as a leading coefficient there, and then I'll have the plus c here. Okay, so we're almost done finding the position function there. And then in order to find the plus c here, I need to go back to this initial condition here, s of 3 equals to 1. So let's just kind of write that down here. So we're given that s of 3 equals to 1 here. So what that really means is that the x value is 3 and the y value is 1. Okay, so if I take a look at s of t here, that gets replaced with 1. So I have a 1 here now, equals to 2 times bracket to the 1/2 plus c. And then basically over here now, this part right here, what that means is this t value has the value of 3, so I have a 1 plus 3 here. All right, so 1 plus 3 is going to be 4. And this is the same thing as 1 equals to 2 times the square root of 4, and then plus c. All right, so from there it should be pretty easy to find the value of c here. So the square root of 4 is 2. 2 times 2 is 4. So now I have 1 equals to 4 plus c, and that means c would equal to -3. Okay, so therefore our final answer, if I go back and simplify everything now, if I go back to find my position function here, we know that c equals to -3 here. So my final answer is now really 2 times, and then I'll write the square root sign now, 1 plus t. And then the value of the value of c is going to be -3 there. And that right there is my position function for this particular problem, given this initial condition at the start of the problem. So s of t equals to 2 times the square root of 1 plus t minus 3. Okay, so a little bit of algebra for that problem, which is fine. Let's move on to the next question here. So same kind of problem. I just gave you a different kind of function here. So there's a ln function now. Now for this question too, if I want to find the position function here, that's the same thing as finding the antiderivative of my velocity function, which is ln t divided by t, and then dt, and then given this initial condition that s of 1 equals to 2. So this s of 1 equals to 2, this actually helps you find the c value. So just remember, this is your x value in a way, and that's your y value there. So we'll be needing that piece of information there to solve for c once we're finishing our antiderivative steps here. Okay, so for this particular antiderivative, let's use u substitution again. So I'm going to let u be equal to ln t. And I know that's going to work because if I take the derivative with respect to t here, the derivative of ln t is 1 over t. And usually what you do next is you take your dt and you just multiply it to the other side there. So this means du would equal to 1 over t times dt. So a very common u substitution step right there. Okay, so if I go back to this side over here, I have the integral here. And remember, ln t, we said it was u, right? So this would be u. And then what we have here is I have a t and a dt, right? So if I move that to the side, that's really like 1 over t. So 1 over t times dt. And you'll notice that this part right here, this part here that I'm circling in red there, that's the same thing as this part over here. So I can replace that all with just du right there, right? So if I just erase all this, now I have just du. Oops, I'll use a blue color here. All right, so I kind of skipped a few steps there, but it's a very common u substitution type of technique there. And from here, what we can do next is we can now find the antiderivative of u. And the antiderivative of u is not too bad because we have an invisible power 1 there. So the antiderivative would be u to the power 2 divided by 2 plus c. So this is what the position function is turning out to be. And now our goal is that we need to find the c value, right? Okay, let's go ahead and plug back u here, and u was ln t, right? So if I go ahead and continue the steps here, this will be bracket ln t squared divided by 2 plus c, and then I have my s of t function over here. And if I go back to the original problem here, we now need to use this to find the value of c. Okay, so let me kind of just erase all this, and let's just kind of I'm going to rewrite the step here as s of 1 equals to 2. So this is, once again, this is your x value, this is your y value, right? So this s of t is going to be replaced with this 2. So I'll go ahead and write that down over here. So 2 equals 2. And then this t over here is going to be replaced with the 1. So this will be bracket ln of 1 divided by 2 plus c. Okay. And that's how you kind of substitute the initial condition back into the problem. All right, so let's go ahead and figure this out. Ln of 1, that's not too bad. Ln of 1 is going to be 0. So now I have 2 equals to 0 divided by 2, which is 0. And then c would have a value of 2 there. Okay. This one we're pretty much done here, so let's just go back to this part right here, and let's just replace that c with a 2 there. So if I go back to this step right here, I can erase that and write down plus 2, and that should be your final answer. All right, so a lot of algebra with the u substitution steps there, but there is your final answer. Okay, let's move on to some physics application problems now, and then this will finish off the homework help video guide. Calculator problem.